The objective of this video is to project the potential impacts on Iceland of the temperature trends that are taking place across 65 degrees North Latitude. How did this objective come about? This channel community published a video recently that projected that North America could, within just a few decades, undergo intolerable, harsh and freezing conditions. The video explained the importance of the line of latitude 65 degrees north that encircles the globe just below the Arctic Circle, and how a drop in temperature along this latitude can lead to the advances of glaciers and ice sheets. We followed up with two more videos: 65 degrees North Latitude and an imminent glaciation of Alaska, northern Canada and the northern states of the USA. Plus 65 degrees North Latitude and the cooling since 1999 of the East Greenland ice sheet and glaciers. Was this leading to another younger Dryas? A future video will bring together these themes and see how they fit into the overall picture of the climate and factors such as the thermohaline ocean circulation, and in particular the Atlantic meridional overturning circulation, and how it interacts with Greenland and Iceland. Before doing so, however, we need to analyse Iceland and how it is impacted by the temperature trends that are taking place across 65 degrees North Latitude. Iceland is an island. Latitude 65 degrees north goes right through the centre of Iceland. Its western edge is 24 degrees west longitude, while its eastern edge is just past 14 degrees west, so we will extend our scan to 12 degrees west. The scan of 65 degrees north relevant to Iceland will therefore cover 24 degrees west longitude to 12 degrees west longitude. The initial time period will be January 2015 to November 2022. But we will also trace any negative trends back to their start date. 24 degrees west longitude had a negative linear temperature trend since January 2015 of minus 1.55 degrees Celsius per decade. The trend started January 2000. 22 degrees west also had a negative trend of minus 1.5 degrees Celsius per decade, and the trend also started January 2000. 20 degrees west was almost identical from 2015 at minus 1.54 degrees Celsius, but this trend started from 2006. 18 degrees west was identical at minus 1.54 degrees and started 2006. 16 degrees west also at minus 1.54 degrees. It started 2006. Coming to the eastern edge, 14 degrees west longitude, it had a negative trend of minus 1.24 degrees Celsius per decade, and this trend started from 2008. 12 degrees west was the same as 14 degrees west, with a temperature trend of minus 1.24 degrees Celsius per decade, which also started from 2008. The scan has finished with the earliest start date for a negative trend being the year 2000. Based on the scan results, our interim observations are the negative linear temperature trends across 65 degrees north started in the west and gradually spread east. The negative trends across 65 degrees north have a higher value in the west and reduce slightly in the east. and a negative linear temperature trend across 65 degrees north began as early as the year 2000 at 24 degrees and 22 degrees west longitude. We now start to examine the projected impact on Iceland. The expectation is that the impact will be large, as the average linear temperature trend rate across Iceland is minus 1.45 degrees Celsius per decade since January 2015. For comparison, that rate is about 13 times greater than the global trend of minus 0.11, and about twice the rate being experienced across North America. So, what would be the projected impact on Iceland? We use this chart of climate variability to determine potential impact. If the temperature across Iceland along 65 degrees North Latitude continues to decrease at its present rate, then in just 80 years it will drop by 11.6 degrees Celsius. That would reduce the temperature to approximately that of the global temperature around 12.8 thousand years ago and what it was 15.5 thousand years ago. The period around 12.8 thousand years ago is especially relevant, as that time marked the end of the Allerod period, where the world was warming after the last glacial maximum, and the transition to the beginning of the Younger Dryas, where the world again plunged into colder temperatures. In Iceland, at that transitional time, glaciers and the Iceland ice sheet re-advanced following their retreat during the Allerod warm period. The projection for Iceland over the next 80 years looks potentially very serious, but what is happening now? To determine the impact, we were influenced by our observations that there had been a spread from west to east and that the initial negative trend started in the year 2000. We therefore decided to gain a further perspective by looking at what is happening north and south of 65 degrees north in two separate scans going from west to east. We also decided to focus on finding out whether each location had been impacted from the year 2000 or not. We start with Grundarfjörður, which is a small town located just south of 65 degrees north and to the far west of Iceland. A negative temperature trend started at this location January 2000. Moving south and east, we come to Borgarfjörður. This is a fjord in the west of Iceland, near the town of Borgarnes. Since January 2000, it has a negative linear temperature trend. We move to Reykjavik. It is the capital city of Iceland, and it has a negative temperature trend since 2000. Further east is the Langjökull Glacier. Again, it has a negative temperature trend since the year 2000. Further east is the Vatnajökull Glacier. It is the largest in Iceland. Since January 2000, it too has had a negative temperature trend. Right at the eastern edge of Iceland, and just below 65 degrees north, is the village of Fáskrúðsfjörður. It has a negative temperature trend since 2000. So we can say that all Iceland locations that we have examined south of 65 degrees north latitude have experienced a negative linear temperature trend since the year 2000. We move to locations north of 65 degrees north latitude. We start at the northeast of Iceland and the town of Bolungarvík. It has had a negative temperature trend since the year 2000. A little further east, in the Drangajökull Glacier. Since January 2000, it has had also a negative linear temperature trend. Further to the east sits the village of Talvik. At this location, a negative temperature trend did not start in the year 2000. It started in 2003. For the final two locations, we will show both the trend since 2015 and its earliest start date. Húsavík is northeast Iceland at 17 degrees west longitude. From January 2015, it has a temperature trend of minus 1.54 degrees Celsius per decade. This trend started 2003. Our final location is at the east of Iceland, at the town of Seyðisfjörður. Since January 2015, it has a linear temperature trend of minus 1.24 degrees Celsius per decade. At this eastern edge of Iceland at 14 degrees west longitude, the negative trend started 2008. From that scan of Iceland, we can say that from 24 degrees west longitude, the negative temperature linear trend across Iceland, locations north of 65 degrees north latitude, began from 2000. From 18 degrees west longitude, the trend began from 2003. From 14 degrees west longitude, the trend began from 2008. In summary, bringing all points together, the average temperature linear trend rate from January 2015 to November 2022 across Iceland at 65 degrees north latitude is minus 1.45 degrees Celsius per decade. The Iceland ice sheet is projected to be, in 80 years, as cold as it was around 12,800 years ago at the time of the Allerod to Younger Dryas transition. If its average temperature linear trend across 65 degrees north latitude continues at its present rate. A negative temperature linear trend across Iceland started as early as 2000 in the east at 24 degrees west longitude. The rate of the negative temperature linear trend has gradually increased from its initial rate for all the steps of longitude examined. There are huge issues surrounding these findings, not least being that throughout the period 2000 to 2022, atmospheric carbon dioxide concentration increased. How can that be explained? And just what is causing this cooling across 65 degrees north latitude that can now be seen to be impacting not only Iceland but also Greenland and North America too, from Alaska to northwest Canada? For now, we have no answers, but our next video will analyse the impact of the Greenland and Iceland cooling trends on the Atlantic meridional overturning circulation, which has a major influence on the climate. Our community combines the topics of globalism, nationalism, climate change, health, and the New World Order. If you would like to join our community, you can find us on locals.com/discover. Just enter the New World Order. This link will take you directly to our site.